Hey guys, now I want to finish up exponential function section while doing these word problems. And one of the application problems we're going to work with is interest, dealing with interest, you all. A couple of things I want to talk about. We're going to talk about compound interest. And there's a formula that I will give to you for compound interest. If P dollars are deposited in an account paying an annual rate of interest R, compound paid in N times per year, then after 2 years an account will obtain $8 according to the following formula. So I'm going to give that formula to you real quick, and that is A equals P times 1 plus R over N raised to the NT. Okay? And I'm going to tell you what each letter represents here. This is when you're doing compound interest. A is your future value or future amount. How much will be in the account, no matter what type of account it is? How much will be in the account in so many years or as a time frame pass, right? So future value or future amount. P represents principal. Principal is always the amount you start with, okay? So principal is the amount you start with. Or I can say starting amount, okay? That's what principal. I don't care if this is an investment account or if this is a loan. Everybody starts at some value, okay? So if it's an investment account, it's how much you put in to start your saving, right, or investing. If it's a loan, it's how much you borrowed. So it's always the starting amount. R is your interest rate, right? And this will be given in percent. So you're going to be given in percent, always given in percent, but you got to change percent to decimal. And you do that by moving back two places, right? Move the decimal point back. When you go to plug this in and when you go to solve these equations, it has to, it has to be as a decimal, not a percent. T here you all represents time. And time here has to represent years. So it has to be in years. If you're given months, you got to convert months to years. We know 12 months make 1 year. So that's how you would convert it. You have to convert it into years, okay? Now, the next thing is and. Okay? And is the number of times that entrance hit the account or interest is added to your account, to the account. Now, and is so important because and can change based on certain wording, right? So there are several words for and. Let me make sure we do this. Sorry. This is compound interest formula right here. I've given you what each one of these means, right? Each letter means. Annual. Once again, and is the number of times interest is added to the account. Okay? There's certain words that's going to tell you how many times. You may find the word, so if you get the word and is the word annually. Annually refers to the number 1. That means it will be added to your account 1 time. Okay? And can also be semi-annually. And that refers to 2. And can also be used as quarterly. And when we see the word quarterly, we know it's 4 times a year. Another word that and can be is daily. And you all, you're thinking daily, you're thinking each day, you're correct. But in the banking system, daily is 360. The bank like to do everything evenly. So it'll be 360. Yeah, we got 360 days, but bank can use 360. Okay. Another word you will hear is monthly. That means every month interest will hit your account. And when we see the word monthly, we use the number 12. Make sure you make a note of this and understand this because you're going to see different words here. You may see, just depending on what the problem is or the situation is that you have at hand. Okay? You will get one of these words to tell you what N is, and that's the number that you have to use to plug in for N. Okay? So let's look at the first one, you all. It says, suppose that $1,000 is deposited in an account paying 4% interest rate per year, right? Compound quarterly. Look at that. Key thing is quarterly. Okay? And look what it says, 4 times a year. So we know our end is going to be 4, right? Find the amount in the account after 10 years with no withdrawals. Like you didn't take anything out. We want to know how much is in here after 10 years, you all. So let's write out what we have, what we know. You're depositing, so that's how much you're starting with. So your P here is 1,000. Next, it gives you a rate. So R is 4%. We got to make that a decimal. Your decimal point is understood to be right here originally. So you got to move back 2 places. So it'll be 0.04. That's what it'll be as a decimal, because that's what we got to use to plug in. The next thing is it says quarterly, and it tells us 4 times a year. So N's going to be 4. And the next thing we got to look at time. Look at time right here. It tells us we want to know the amount in this account after T equals 10 years. Okay. So we got that, right? We got everything we need. Now we got to plug it in because we got to find A. Let's plug it in. A equals P times 1 plus R over N. I like to write the formula and then plug it in. You don't have to. You can go ahead and plug it in. So we start with 1,000 here. Then we say 1 plus 0.04 over 4, right? That's N times 4 times 10. Now, you all, before I put this in my calculator, I just like to simplify things. That's just me. I like to try to simplify as much as possible, right? So then here, I can simplify a couple of things. 1 plus, if I want to, I can put this in the calculator real quick and figure out what that is. So let me bring my calculator out real quick, you all. Let's do that real quick. We get 0.04 divided by 4. Look what it gives us, 0.01. Okay, so that divide evenly. So I can make this I didn't put it right, 0.01. And then the next thing, you all, is can't we multiply this out and get one number for the exponent? Yeah, that gives us 40. Now, we can put this in the calculator like this. You all, please understand, do not round early. If you round early, it's going to throw your answer off. Round at the very end. You all have a graphing calculator. Let's put it in. I want y'all to see me put it in, okay? So let me get my graphing calculator. Well, look what it says, 1,000, right? And then I'm open parentheses, do 1 plus 0.01, close that parentheses. And then I'm going to hit this to give me exponents. You might move there. Y'all might have the actual symbol. And I'm going to raise that to the 40. Make sure everything look right. Then I'm going to hit enter. Okay. I did something wrong, you all. Okay. So let me go back and make sure I'm writing it correct. Okay. Raise to the 40. Yeah. Did I do something wrong? Okay. Let me do it again. 1,000. Parentheses, right? 1 plus 0.01, close parentheses. I'm going to raise this to the power of 40. Yep. I don't know what I did wrong the first time, so I must have not put something in. But be careful because y'all see I made a mistake. We are talking about money, you all. So you see 0.863. We would need that 3 to tell us if we round that 6 up, which that 6 wouldn't round up. It will stay the same. Okay? So let's do it. So future value in 10 years, you will have 1,400, what is it, 88? I think it is 88, sorry. Yeah, it was 88 and 86 cents in this account in 10 years. That's what we will have in our account in 10 years. Okay. Now you all still dealing with this. So you started with 10 years ago, you started with 1,000. In 10 years, you got this amount. We want to know, Part B said, how much interest is earned over 10 years? How do we know how much interest is earned? What you do is you say interest equal, I equals the future value minus what you started, the principal. That will give, excuse me, that will give you interest every single time. Okay, every single time. Now, let's do it. I equals 1488 minus 86 minus 1,000. I now equals $488.86. So in 10 years on the account that was started with 1,000, interest rate was 4% quarterly, you're going to accumulate $488.86 of interest. Well, almost 500 if you want to round it. It's 500. But you got to give exact values here. Okay. Now, I have more problems I'm going to do, but I just want to introduce this to you real quick, and I hope you understand. Make sure you understand the formula. The biggest thing here when you're doing these, and I got a couple more, when you're doing these and you're plugging this in, please be careful. Do not round early. Round at the very end.